let's solve this problem. And I'm going to solve it in quite a bit of detail to reinforce the lessons from the lectures. So we have two firms, firm 1 and firm 2. The problem of firm 1 is to maximize 1,000 minus Q2 plus Q1, that is the price that can be supported at those two quantities times Q1. All of this together is the revenue that the firm gets minus 100 Q1. And this, of course, over non-negative quantities. The problem of firm 2 is to maximize over non-negative quantities the same aggregate inverse demand function the marginal cost of this firm is 200. Now, as we've seen in the lectures, in the theory, the first order conditions for both firms are going to look like marginal revenue for 1 equals marginal cost for 1, and marginal revenue for 2 equals to the marginal cost for 2. Now, what's the marginal revenue for this first firm? If you take the derivative with respect to Q1, and the key is holding this as constant here and this as constant there, what you get is minus Q1 plus 1,000 minus Q2 plus Q1 equals to 100, which is the marginal cost in this case. And here what you get is minus Q2 plus 1,000 minus Q2 plus Q1, this is the marginal revenue in this case, equals 200, which is equal to the marginal cost in this case. Now, if you work with both equations, what you get is a system of two equations with two unknowns, which are 1,000 minus 2Q1 minus Q2 equals 100, and 1,000 minus Q1 minus 2Q2 equals to 200. And if you do the algebra, what you get is that Q1 is equal, or Q1 star in equilibrium, to 1,000 over 3, and Q2 star is equal to 700 over 3. Let's check our economic intuition a little bit. It would make intuitive sense that the firm that has a lower marginal cost will end up producing more, and that is indeed the case. By the way, a small tip for this class of problems: if you want to check that your solution is correct, one thing that you can do is obtain the solutions, go back and plug them back in the marginal revenue equals marginal cost equation, and check that everything holds. That allows you to check your algebra, and this is the case here.